Welcome to Study Loop.
We're asked to show that this second order differential equation a y double prime plus by prime plus cy equals 0 always has a solution that goes to 0 as the independent variable, say x, goes to infinity if a, b, and c are all positive. So I don't know if there's any clever way of doing that by taking limits of the differential equation, but we can just look at the solutions. So we know the solutions of the form a e to the lambda x, and plugging that in, we get the equation a lambda squared plus b lambda plus c equals 0. Solving for lambda, we get that equals negative b plus or minus square root of b squared minus 4ac all over 2a, just the quadratic formula. And so what we can see here is that we get solutions that look like lambda equals c1 plus or minus c2. Okay? And I'm just going to call it that. So then we have e to the lambda, and that we can write as e to the c1, e to the plus or minus c2. So we have two solutions, and so here, this is our general form here. So we can see we can pull these out, right? And so we can see c1 is always negative, right? c1 is always negative. So that means that this is always exponentially decaying. But, and c2 is always positive, right? So that's just this part here, and that's when we're taking the positive square root here. Is either always positive or imaginary. Right? If it's imaginary, then these are bounded by 1. So we have exponentially decaying always. So these are about if c2 is imaginary, then these are sines and cosines, and these are bounded. Right? So and then these are exponentially decaying. So overall, this is all exponentially decaying. Now, if this is a real number, we need this to be this one here. If this is a real number, we need this thing, C2, so the plus sign, we need it to be exponentially growing slower than this is exponentially decaying. So that C1 plus C2 is negative. This one will always be decaying. So C1 is always less than 1, or less than 0, we said. So is C2 greater than C1? Well, basically, we just need to look at this. So minus b plus square root of b squared minus 4ac. Is that going to be less than 0 always? So that would be the exponent of this term here, e to the, over 2a. So what we can see here is that this thing here, this thing is always going to be less than b, because this thing is always positive, and so we're going to have this thing is always going to be less than b squared, so the square root of that is always going to be less than b, so this thing is always going to be less than 0. So that means that C2 is in fact always greater than, let's see here, C2 is always going to be less than C1. So we have, and so this answer to this question is no, because this. So these will always have negative exponents, or exponentially decaying oscillations.